All right, so how do we determine if it's a vertical asymptote or a hole in a rational function? It's actually not that hard. I went ahead and I set up four functions over here so we can look at the differences and make some results out of there. So I'm going to start with 1 over x plus 4 and x minus 3. And as we look at this graph right here, you're going to notice that it comes with a formation, and we can tell that there is a vertical asymptote that is running vertically at -4 and at +3. Remember, we still are using the opposites of those binomials that we've done in many of our factored form stuff. So what we can determine here is that we have one at x equals -3, we have one at x equals a +3, and one equals to -4. Okay, and both of these are vertical asymptotes. And the reason why is, well, they separate the graph. There's a distinct, defined break in the graph vertically, okay, at those values. So now let's look at the next one and see what happens there, okay? So I'm gonna turn that one off, and let's go ahead and turn this one on. Now, what you're gonna notice is that x equals to 3 is still a vertical asymptote, okay? So x equals to 3 is still a vertical asymptote, but in this case, this is no longer a vertical asymptote. Okay, notice what's happened is the -4 has gone away from a vertical asymptote, and it is not showing up as a distinct value. Well, if I trace this graph to -4, check it out. If I trace this graph to -4, you're going to notice that that value at -4 states it is undefined, and it is undefined. So that is what we'd say we still have a break in the graph. So x equals to -4 is not a vertical asymptote anymore. It is a hole, and x equals to 3 is a vertical asymptote. Okay, because there's still a distinct break. Well, what happens in the equation to identify that? Well, that x plus 4 cancels completely out, and we get 1 over x minus 3. So that becomes a complete break in that graph. Now, we can keep going with this. Let's go ahead and look at 2 more real quick. And it's just an extension of what we already have. If I was to look at this one in this case, notice that x minus 4 and x equals to +3 are vertical asymptotes again, okay? Now let's look at why that is occurring, okay? Notice that x plus 4 and x plus 4 cancel, and we are still left with 1 over x plus 4 and x minus 3. Both of them are producing vertical asymptotes. And the reason why is because they're still in the denominator. They are not getting canceled out. So can we make a prediction on the next one? Well, let's check it out. If I cancel x plus 4 and x plus 4, I am still left with x equals to -3, which tells me I'm thinking 3 could be a vertical asymptote and -4 may be a hole. Okay, so let's go ahead and turn that one on and take a peek at it. Okay, so I look at it and check it out again. I've got a vertical asymptote right over here at +3. That is staying as a vertical asymptote, and this is showing up as a hole. So one of the ways we can determine if we have a hole is that if it is canceling out in the denominator, and that will give us an undefined hole in the graph. And if it's a vertical asymptote, that factor will remain in the denominator.